Realizing that we're about at the end of the semester here, and I haven't even started giving out the main barrage of homeworks that I was planning on doing, that I was preparing you for with all of this database description work, database SQL stuff. And so, since we didn't have class on Friday and I didn't have a chance to drop homework 3 on you, in fact, I wanted to jumpstart the projects with homework 4. I am officially assigning homework 3 today, due 1 week from today, next Monday, but I also want you to know that on Friday I'll be dropping a second assignment on you, and it's going to be much longer than homework 3. So if I were you, I would try to get homework 3 turned in and done. It's relatively simple before I drop homework 5 on you. So 2 homeworks will be due next week, 1 on Monday, 1 on Wednesday. Monday should be relatively short. It's basically just coming up with relational algebra expressions and SQL expressions which work on database tables that you create in Microsoft Access. What tables do I want you to create in Microsoft Access? I want you to choose 2 or 3 or 4, most people just choose 3 tables from the university database schema, that sheet that you have on you, and fill each table with 5 or 6 rows of data and write SQL queries that apply those relational algebra expressions to those tables, demonstrate that this is a selection, this is a projection, this is a Cartesian product, and so write out the relational algebra expression in RA, and then actually write out the SQL query in SQL, and then show me the result. And also show me what the data is, give me screenshots of what the data is in those tables to begin with. So generally, you're going to choose like 3 tables that are all interconnected so that you can use 1 or 2 of the 3 to illustrate each one of the relational algebra expressions. Does that make sense? I tried to explain the same thing with more words. Most of these SQL queries should only use 1 table, but some like Cartesian product and comma join will use at least 2 tables. So if you create, and again, you can just create your data. You just use the structure, the schema that is described for you for the 3 tables that you choose, and then fill in those tables with whatever data fits that schema. So name, course title, course ID, or whatever those values are. Just fill in those tables with data that looks more or less reasonable, and then come up with some SQL queries that generates a non-null result on the data in those tables. You don't want to write an SQL query that returns no data. That's uninformative. Make sense? Again, I think homework 3 is going to go much more quickly than homework 5. So I encourage you to get that done, if not turned in, before this Friday, when I will be giving you homework 5. From this point on, I'm going to start preparing you for homework 5. Also, you might want to expect that I'm going to give you another database assignment every Friday for the rest of the semester. Okay. So 1 a week. I've got 3 or 4 of these things lined up, and I feel like I've got 3 or 4 free weekends or Fridays in this classroom where I can give you 8 weeks to do the assignment. So the last Friday before the end of the semester, I won't be giving you one, since that Friday will end up being in like finals week or something. Actually, I'll probably stop giving you assignments a couple of weeks early, just because I'll want to give you like 2 or 3 weeks for the final project, which will be an extension of what we're doing, of the stuff that we're doing in these upcoming assignments here. I'm having you do some data work on wind data, the wind data that I had you do the last homework on. And then from what you learn about working with that data in these upcoming assignments, you'll probably want to do more or less the same thing for your final project data, your airfares data that you've all been collecting. By the way, how long should you keep on collecting airfares data? Probably another week or so. But after about November 10th, you probably don't need to keep on collecting data. At some point, when I'm going to get the entire class together and have everybody compile all of their data into a single database, at that point, there is no point in collecting more airfares data. Any questions? Homework 3 is up. Homework 5 is actually up. You can access both on D2L, but homework 5, I feel like that's going to take more time, and I don't believe I've covered everything I need to cover for homework 5 to make a whole lot of sense to you. So why is, I don't want this selected. There. Okay. So I just want to give a quick overview of this wind data that I had you compile for me. Have I had you guys run a select into query for me yet? Have I talked about it in class? Have I talked about how to gather all of Bemidji's data into a single table just by adding the into keyword to a select query? I feel like I may have talked about it in passing. It's actually going to be fairly important in getting homework 5 done. But this is homework 4. It was due last Friday. I just graded it and made that live for you. And so those of you who did turn the homework in probably turned in some series like this. This is a
scatter plot.
Pardon?
Scatter plot.
Hey, this is a scatter plot. Thank you. This is a scatter plot of U values and V values for the wind from July 2nd, 2022 to July 4th, 2012, not 22. July 4th, 2012. And I really like this illustration. I'm sure that this person gave me a key. And basically, this homework was all about just making sure that you guys can give me there it is. You guys can make me a chart with labeled axes and legends and dot plots, scatter plots. In the future, you may want to connect your dots with lines. Some people just show just lines and don't even show the markers. I like seeing both, but it can be pretty messy, and graphs do look cleaner as just lines and no markers. But I would stay away from not having any lines at all, because then you kind of have to do the dot connecting yourself, and that's harder. But so I see that the blue dots are U values and the red dots are V values. Anyone remember what the U values are in wind data?
East and west.
Pardon?
East and west.
East-west winds, yep. Do you remember what positive U values are?
Either east or west.
Yeah. I feel like positive values are probably east and the negative values are west. It probably doesn't matter necessarily, but if imagine if these dots were connected with lines, what's going on with this blue series here? What happened right about here? That seems sort of interesting. What did that wind station detect?
Very strong gusts.
Super strong winds in one direction, right? Let's call it east, and then suddenly in almost the very next data point, super strong winds in the other direction. What does that mean?
Whiplash?
It feels very whiplashy. tornadic?
Yeah.
Yeah, although these were supposed to be straight line winds, but yeah, it does feel like a very important shift happened right there. It's sort of like the eye of the storm just passed over the wind station. And so now the eye of the storm is generally a round sort of thing, even if it is driving a linear wind. And I think that's what happened exactly. That was captured in that 20-minute reading, because up to that point, winds were blowing very strongly in one direction, and it looks like they started blowing slightly less strongly in that direction before suddenly going in absolutely the other direction, and then, still blowing in that direction, tailing off as the storm left the region where it was being measured. And so that's pretty interesting. Did we notice any really sort of major changes in the data that we're visualizing here in our other graphs? Do you remember what your other graphs were? One of the main reasons I assigned this homework to you is I asked you a lot of opinions. I asked you, what do you think the units of measure were? What do you think this means? What do you think that means? And since basically what I'm asking of you is opinions, because you're not professional weather scientists, whatever you said that seemed to hang together relatively well, I just gave you full points for it. It was very hard for me to take away any points, unless you just didn't answer any questions here. This, I was just having you demonstrate that you know how to take those wind events and make wind speeds out of them. By the way, that very big eastward wind followed by that very big westward wind, that basically makes these dots right here, right? That's, so if we're just looking at a wind magnitude chart, we don't actually notice the point in time when a storm cell or a storm eye actually passes over the sensor like we do here. That's one reason that we want to see the same data in several forms. A U and V form, even though it's kind of messy having to take a blue point and a red point and mash them together somehow and make sense out of that. But what's nice about this is we just saw something important happen right there. That was the top of the storm right there. That was the strongest moment. And that was over 40 minutes. Actually, that was over an hour, because we have this point here, and then this point here, and then this point here, and each of these points are being collected every 20 minutes. And so the strongest part of the storm actually lasted an hour, which seems crazy long to me. Usually a big thunderstorm, the peak of the storm lasts like 5 to 10 minutes. That's probably why there was so much damage. Okay, so that's another interesting graph where this is normally how we would describe storms. We're talking about 80-mile-per-hour winds or whatever, and that's the sort of graph that we would expect to see. What's going on with this graph? Barometric pressure, what is that even? I'm looking at these Y values, and I mean, the values are barely changing, right? All of these values are like between 28.2 and 28.4. Normally, you load up data like this, you make a graph of data like this, and if you don't change the y-axis, then Excel chooses your range for you. And the reason I told you to set your graph to this range, does anybody have an idea why I asked you to set your y-axis to this particular range?
There's a really bad outlier.
There is a terrific outlier. It happens right between these 2 points here. Do you remember what that value was?
I think it was just like negative, wasn't it? It was -1. I just removed the data point and it did it for me.
Yeah. Yeah. -1 or 0, but yeah, I believe it was -1. It was something that the sensor could not interpret, and I don't know what time did that occur. what do you suppose was happening in that other graph at right about this time? I think that's when the eye of the storm passed over, right? Something important happened right here. We can see it in two graphs. And yeah, that's when the barometric pressure went from pretty much going downwards all the time to, for some reason, starting to go back upwards all the time, going into a increasing sort of pattern. That was, again, feeling the storm approach and then feeling the storm move away. I feel, that's my interpretation anyway, my opinion. Again, I'm not a weather scientist. I'm just claiming 3 points here. So, otherwise, a lot of people said that they thought that the units of measure were meters per second. And again, this was just an opinion that I solicited from you. And so, even though I don't believe that's correct, I did not take off any points for most people or for anyone, for number 6, I believe. But one thing that's very important for me to remember, and I often forget, is when I'm going out onto the internet and collecting data like this that I'll be using for years and years afterward, it's very important for me to remember to grab, there's usually some sort of README file or some sort of schema file or something that actually shows what the meaning is of values in columns for the Excel files or the CSV files that you're downloading. And so this is actually the design, the schema of the data that I downloaded. And so we have a time column, a true direction column, a speed column. And by the way, a lot of these columns show you the units of measure for the values that are collected. It turns out for the wind speed, it was in knots. Only one person guessed knots. And even if you had looked into knots, knots didn't seem to fit as well as meters per second either. And I think it's because a lot of people were expecting knots to, or the values to be, to approach the values that you heard talked about in the videos, like 80 miles per hour, and nothing approached 80 miles per hour. If there was 80 miles per hour winds, it was probably in terms of wind gusts, but where did I see, maybe it's further down here. But this is actually where I came to the theory that, oh, here they are. So again, speed is reported in knots, but also the knots that they're acquiring is based on a 2-minute average. And so I probably wouldn't have guessed myself without seeing this metadata that the values in my data set were average data, average values. And so it's completely possible that there was an 80 mile per hour or whatever that would be in knots, 50 knot wind at some point. But if that 50 knot was averaged together with a 40 knot, with a 20 knot, with a 15 knot, then maybe the average knots never actually went up above 25 or something. Again, I don't really have a good feeling of what a 25 knot wind is and how it's different from a 45 knot wind, but the fact that these seem to be based on 2-minute averages is makes those values make sense to me in a way that they did not make sense to me when I was trying to figure out those units of measure. By the way, why am I just trying to get you guys to figure out what units of measure are and having you listen to various randos on YouTube videos about this event? Just to get a sense of ground truth, right? Just to get the context of this data and see if you can confirm by looking at the data the things that these people are talking about, and maybe the things these people are talking about will allow you to understand this data better when you get at least partial confirmations of what they were talking about in the data that you're looking at. So it didn't matter to me whether you were right or not. It mattered to me that you were checking the veracity of your sources. By the way, one thing that you might notice here is that there is no column of data that talks about wind velocity or anything that is broken into U's and V's. I actually did that. I took that wind speed and I just extracted the x component and the y component from that value that they gave me using sines and cosines, and that's the data that I gave you. Because if I didn't, then all you would have been able to build out of this data would have been that magnitude graph, and I really wanted you to see that eye of the storm passage event that happened, and that's only visible in the barometric pressure graph and the UV graph. And again, it's nice for you to see the same event in more than just one measurement. So I didn't want you just to see it in barometric pressure. I also wanted you to see it in some other data value. And so it's interesting that that eye of the storm passage event is completely invisible in wind magnitude, the way that we're getting this data, but with a little bit of processing, a little bit of sine and cosine knowledge, suddenly you can see that there's this huge wind shift happening in what otherwise would just seem to be very similar wind magnitude data. All right, I think that's all I'm going to say about homework 3. I'd like to start talking about homework 5 here. And so, let me open up a whole new PowerPoint that is also up on your D2L. So everything you see in class today, you'll be able to review in D2L if you need things to make more sense. But how many of you have learned how to do linear regression in a math class or a geography class? Or what is a linear regression? It's like figuring out, getting a whole bunch of data and then, sort of mashing it together in such a way that you can get a value of m and a value of b out of it, so that you can draw a line in y equals mx plus b fashion, which magically just goes through the entire cloud of points of the data that you mash together, it's as close to the middle of all of those points, as close as possible to all of those points simultaneously as it can possibly be. It's mathematically proven. And so that's what I want to talk about today, in case you haven't encountered that in one of your applied math courses. So I'm just going to start with a simple data set here that I have in a database. This table is called California income. What this is a median California household income from 1995 to 2002. So this isn't, 53,807 is not the maximum salary or combined salary that Californians were making in 1995. This was the middle salary that the average household was making in 1995. Median is kind of like the average, but not necessarily exactly the same all the time. And so what we see here is from 1995 to 2002 that the median California household income seemed to be, going upwards. And it seems like there was a pretty big jump between 1998 and 1999 for some reason, maybe the passage of some sort of tax rebate or something, but up to that point it was increasing by, about $1,000 a year, maybe. And suddenly there was an $8,000 jump, and then, a $100 jump, $600, and then another $1,000 it looks like. So, I don't know, the average yearly increase is probably somewhere between $500 and $1,000, probably something like $700 maybe, if we were just to take a wild, off the top of Professor Neville's head guess at it. Would you agree? That's my data set, in any case. In fact, we see this data set in a lot of introductory statistics classes. You'll probably see this again. It's used in a lot of textbooks just because it's relatively easy. The reason that we use a list of data like this is usually because we're going to try to use it to predict the future. I want to see, okay, well, if our median income seems to be growing by about $700 every year, what would our median income likely be in 2003, 2004, maybe 2 times 700? At least it's a fairly good guess. And then we actually have to wait until the data comes in 2003, 2004 to see how close our guess was. But often, making guesses based on averages, like making guesses based on medians, keeps your guesses fairly stable and relatively accurate if you have enough data to derive averages or medians out of it. Can we trust that pattern to keep on going through to 2019 and 2020? Maybe, but would we trust those values as much as we trust the predicted values for 2003, 2004? Maybe not. Probably the values closest to the actual data that we collected off of the ground, the predictions generated for those years is going to be more accurate in general than the predictions generated for these years. But as long as we assume that we don't hit a major recession, major multi-year recession, and people's salaries start going down, assuming a continued upward trend through 2019, 2020 isn't a terrible idea. I would just assume that our difference would start, our error would start getting bigger and bigger the further away we get from actual real data. By the way, when we are generating predictions like this, even if we have at the end of 2002 predictions for 2003 and 2004, we should not use those two values to try to predict 2019 and 2020. You should not use synthetic values to generate yet more synthetic values. You should only use real life values to generate any predictions at all. Synthetic values are nice to have, but they cannot be inputs to your prediction models. Any questions, comments?
So how would we form those new prediction values based on what data we already have?
Yeah, how would we come up with those predictions?
Yeah, basically.
That is what I'm about to tell you. Okay, so some things we can observe about this data. One thing I've already said, clearly the trend in this data is that it is going up year over year. What kind of graph, if I were to put this data in an Excel sheet and then make a scatter plot of it, what do you suppose that graph would look like? So some points, some more points, and if we had a line fit to those points, it would probably be going up with a positive slope. So you already kind of have a picture in your mind of what you should end up with this data. Even though you don't know exactly where these points will end up, you already know kind of what that graph should look like. And so when you make this graph, that should confirm your intuition. It shouldn't be far off from what you're seeing in your mind's eye right now. But this is what the graph actually looks like. And if I were to create a line that passed as close as possible to all of these points simultaneously, I guess I did not draw it, but you can imagine that it would go up through those two clouds of points, something like that. One thing that another thing that we can sort of come up with is, on average, how much does this Y value increase per year? I mean, all that is probably figuring out all of these differences and, kind of taking the average, right? And how do you suppose that average would be represented in this graph? That average is probably going to be the slope of that line, or pretty close to it anyway. So we already have, just from this raw data, a pretty good idea of what the slope of this line is going to be that goes through this data. So how can I generate a linear fit to this data? Well, if this data is in Excel, there's probably already a menu option that will generate that linear fit for you. I'm not going to demonstrate that today, but I can at a later date if you need me to. Generally, you can just right-click on any point in this series and then select from the pop-up menu do a fit to this data. Another question that you should ask when you're trying to come up with equations that explain data is, should it be a linear fit? And how do I answer that question? Well, I mean, because this doesn't completely look like a straight line, right? But we only have one measurement per year, and a straight line looks okay, and I don't think, I mean, what are my other options? I don't think that this really looks logarithmic. I don't really think that this looks parabolic. And so out of the choices that I have, probably a straight line is the most obvious, the model that makes the most sense, the graph that makes the most sense for this data, even if it's not in a perfectly straight line. So you should at least consider your other options and then have good reasons for saying, well, probably the linear model is my best choice here. And that's all I want you to consider by asking these questions, which ultimately I'm going to ignore. Make sense? Any questions on that? So, the formula generated by a linear fit, it should eventually give me a slope, it should give me a y-intercept, it should be in the form, or at least rewritable in the form of y equals mx plus b, right? Something that's easy for us to work with. We know that m is going to give us the angle of the straight line on the graph. We know that b is going to show us where that line crosses the y-axis on the graph. How about the range on our x-axis? So right now I have two columns, a column of years from 98 to 2002, about 8 years worth I think I had. Looks like 7, 8 years worth. And is there any reason why I should change that range to 0 through 10? Something that I want you to keep in mind, because the range that we choose for x-axis is actually going to have an effect on what that slope looks like, because how do we make slope? It's y2 minus y1 divided by x2 minus x1. And so if we're subtracting 2,000 numbers from each other, that might give a very different value than subtracting like 3 from 7 or something. Well, this is the real reason. If we use the years 1995 through 2002, then where's the y-intercept going to be? The y-intercept is going to be at 0 AD. Is that where you want the y-intercept to be? Again, we can look at the results of going with this and see which one of these intercepts we like, because otherwise, if we're just using 0 through 10, then basically we're subtracting 1995 from all of our values. So this will be the value 0, this will be the value 7, and so the y-intercept in that case will be in 1995 AD. And maybe that's just prettier for you to look at. Maybe that's a value that makes more sense to you. Again, there's no real right or wrong answer here. It really depends on how explanatory or how interpretable you want your final graph to look from just the numbers for your important variables like m and b. So in order to test these two theories, I'm just going to create an additional column of values in my Excel table created by subtracting the first year value from all of the year values, and that gives me these, what I call the zero-based year values, but really the meaning of those values is the years since 1995, if I had to give that column a name. Does that make sense? All right, so I'm just going to skip straight to the good stuff. If you want to know how to take all of those numbers in that table and make an M out of them, you basically just need to do a whole bunch of summations. You need to, for every row of data, multiply the x to the y and sum all of those products together. You want to sum up all of the x's, sum up all of the y's, multiply those two sums together and divide them by the number of data points that you have. You also want to take all of your x values and square them before summing them together. You also, at some point had a sum of x values here. You want to take that sum there, you want to square it and divide it by n, and then you can put all of these things together into a magical equation, which, when it delivers a value, will be the value m. It will be the perfect slope for the line that passes as close as possible to all of the points in your data set. But, you know, there's an infinite number of lines with the same slope. The other value that you need to know is, where does this line cross the y-axis? That's going to put that line exactly in the middle of that cloud of points. That's what's actually going to make that line as close as possible to all of the points simultaneously. And it turns out, if you already know what m is, and you can figure that out at any point using this equation, then you can always figure out b, because all you do is figure out what is the average of all of my y-coordinates, what is the average of all of my x-coordinates, take the x-coordinate average, multiply it to your m, subtract that product from your average y, that will give you your b. You know, if I were you guys, I'd have my notebooks out right now and I'd be copying those formulas down, but of course you guys know that this PowerPoint is on D2L, and so you can just copy it down later. So, okay, I guess that makes sense. Hey, let me run through a quick linear fit example of this data by hand in Excel here. Again, I assume that most of you know that Excel functions exist, right? That we can, in any Excel cell, create a mathematical expression starting with the equal sign, and then that expression will take whatever other data is available to us in that Excel file and generate the result defined by the expression. So I just have a linear regression file here, which actually I have also put a copy of this up on D2L, so you can do this exercise at home tonight and impress your parents and your friends and your roommates. I have my 3 columns of data over here. I want to come up with all of the points that my perfect line goes through here, but first I have to figure out values like x squareds and x times y, and the sum of those things, the sum of my x's, the sum of my y's, and then how many points in total, and then I put all those things together according to those equations that I failed to copy down 2 minutes ago, and that will give me m and b. All right. So, this is where I'm sad that nobody copied down those formulas, because, well, at least I can figure out what sum of x is. This is just going to be equal to sum of everything from here to here. By the way, I chose, since 1995, as my x coordinate, because I just think that's prettier. Again, these equations aren't going to work if they don't start with equal signs. This is going to be the built-in function sum in Excel, and I'm just summing together all of my y values, so that's my summation of y's. There, I hit tab, and the thing, the equation, the expression evaluates. I want to count up the number of points here. It doesn't really matter what I'm counting. I just know that there is a count command that will count all of the stuff that I want to count. And so this is just going to say, oh, there's 7 values in that rectangle. Oh, 8 values that you just highlighted. Okay, so that's that. What are x squareds? Well, this guy, actually, I have a formula here already that's c3 raised to the 2 power, c3 squared. And so if I were to grab this drag box here and drag it down, then the address that I'm grabbing my data from actually changes relative to where it was dragged from. So since the first data was grabbing its data from here, then 1 row down, it's going to be grabbing its data from 1 row down. All right, so there's that. And so I'm just going to populate the rest of that column with that equation. And then this is doing the same thing. 0 times anything is 0. But when I drag that down, instead of multiplying the value in those 2 cells, it's going to be multiplying the value in those two cells, so that seems to be working. I will drag that down, and once I have these values, I can just sum them together. And so, you know what, actually, I can just copy, Control-C, paste this function here, which is summing together all of these values, and the same thing will happen. If I copy it over four or five columns over and paste it there, it's actually going to grab its inputs from 4 or 5 columns over. And now I'm just going to drag this over. All right. And so I didn't want to have to type this business in and possibly make a mistake. And so I'm just going to ask you to trust me that all of these cell addresses, I12 minus C12 times D12 divided by E12, all divided by the expression H12 minus C12 squared divided by E12, that is actually the implementation of all of those summation equations that give me the value of M. And that's going to give, so once that evaluates, whatever that slope is, will be an M in that cell. And I guess it was closer to $2,000 a year that was going up. I did not expect that. But again, it's average, and there was one year with a big jump, right? What was it, like a $5,000 jump or something? And so maybe spread out over those 7 data points. Even though most of them look like about 1,000, it ends up being 1,800 instead. And then once I have a value here, I just plug in that value, into this expression. And so, it's this E15 value, grabbing the value from this red cell here. That's using M. And otherwise, it's using Excel functions to figure out the average of all the numbers in these boxes here. All that makes sense, even though I'm just racing through it, because I assume that you understand that these Excel functions make sense to you. Also, I only have 7 minutes in class left, so that's why I'm going so quickly. And finally, I want to have values that I can plot a line out of. And so I already have an equation in white here. I'm just going to make it black so we can see its value. But I'm going to double click on it so we can see what the formula is and where it's getting its values from. And apparently what I'm doing is I am taking this x value and multiplying it to this m value and adding this y-intercept value to it. I'm basically doing y equals mx plus b here, right? This is the mx plus b equation, and what its result will be is y. I am generating all of the points y on this average line that is going through that cloud of points there. And so 0 times slope plus b is 52857.25. That makes sense because the 0 actually killed its x value, and so this is basically the b value. But that y equals mx plus b now is generating different values from anything else that we're seeing on this chart. And now, if we were to plot these points with this being the x-coordinate and this being the y-coordinate, what we would see is these points are all climbing at a rate of 1877.25 units per year. And they give us a line that looks very much like this. This is the line whose equation is 1877. It's rounded this to 0.3 because for some reason it decided it only wanted one digit after the decimal, but that's basically 0.25. And then plus 52.857, and then rounded down, it looks like. So Excel is taking some shortcuts, but it is actually implementing these floating point values. And this is the line that we just created with that linear fit there. So really, in order to do a linear fit, all you need to know is those two equations. You don't need to know why those equations work. You don't need some mathematician to come along and give you some sort of mathematical proof that you don't care about. You just want to have the two equations that you can plug into your program or your Excel, and you're basically done. I'm going to ask you to use that knowledge in homework 5, come Friday's assignment. Okay? Any questions on this? Can we all use those formulas? Is that fine? We've been talking these last few weeks about SQL commands, SQL keywords, select statements. Can we select a bunch of data out of a data set, maybe just 2 columns of data? And maybe we assume one of those columns is an X coordinate and the other column is a Y coordinate. Is it possible to write an SQL query that mashes all of those values together in some way that it delivers to us a value for M and a value for B? What would that SQL query look like, Matthew? It would look murderous. That's what it would look like. So to make your lives just a tiny little bit easier, and actually I don't think you do need to know how to do this in homework 5, but to make your lives a little bit easier, I actually gave you that SQL. What is this SQL doing? I'm getting the sum of all of my year values times my household values and subtracting from that the sum of my year values times the sum of my household values. This feels like sum of x's times sum of y's, right? Divided by the count of all of my values. That feels like n. All divided by, with this green thing, all of this stuff inside the blue parentheses in the denominator, that's going to be the sum of all of my squared years minus the sum of my years just squared, all divided by the number of points that I'm mashing together here. Does that, I know that nobody has memorized that formula for M yet, but does that feel familiar to you as the formula for M? That's good, because I am renaming this entire result, which these are called aggregate functions in SQL. I haven't gotten to them yet, but they are at the end of chapter 3. And so a lot of these functions have the same names as the functions I just used in Excel, but we're actually in a different language. We're in SQL. We're not doing Excel functions, but it's not unusual for a sum function, no matter what its language, to have the word sum in it, or count. Anyway, I'm grabbing all of this data, year and household data, from this table named California income, and then and aggregate values usually just return one value, and all these single values are being combined and multiplied, divided, subtracted, whatever. And so M is just going to be one value. I'm not returning a whole column of different values here. This is only returning one value, and its name will be M. But what I am also doing is I'm going to use the union keyword in SQL, and I am going to glue to that one M value that's coming out of the top query whatever comes out of this query. And this query is take the average of all of my x coordinates and subtract from that I guess this is the average of all of my y coordinates minus the average of all of my x coordinates times M. Does that sort of feel like the formula for B? It should be reminiscent of that, because that's exactly what it is. But what is this value M? I can't just write an SQL query and create a value here and then use it later on in the same query. But just to show you how I'm putting these two things together, I am actually just going to union these two results. What does union do? Lucas? It does a vertical gluing, right? It's going to glue the M value to the on top to the B value on the bottom. I didn't bother renaming this to B here. All I know is I need to use M in order to get B, and this will be the second value in my column. My column will only have two values here. Let me prove to you that this works. I mean, I don't want to just give you random SQL code and then have you go into a Microsoft Access database and have it not work or something. So my Microsoft Access database had better have a California income table, otherwise none of this is going to work. I didn't give you this database, by the way, but I bet that you could build this easily enough if you needed to. And so, yeah, this is the same data, right? And so I'm just going to go and create this query, and I've basically copy pasted that in, but I'll just do it again since I went to the trouble of. Oh, this makes sense? This is actually not going to work. Do you know why it's not going to work? I just told you a minute ago why it's not going to work. Caden, what do you think? What do you think is the problem here?
You didn't replace those values.
Which values? There is a value I didn't replace. I mean, it's good to know in general what the error will be so that you can interpret the error message, but let me just show you the error message. Did I not click on that? What?
It's got both of the CI income highlighted, so I'm guessing there might be a problem there.
Yeah, it's not that. Well, this didn't fail this badly in my office. This should be working. So I undid the copy paste that I did. Will this work better? What the heck? I do have a California income table. It's right here. Okay. Well, the main problem is I'm using M here, and again, I owe as M. No, that's there. And so I can't just create a variable in a query and then use it in that same query. What I'm going to need to do, I don't even know if this is going to work since it refused to run in the first place. Control C. I need to redo that entire expression to get M so I can multiply it to average of year. Control V. I believe that should work. Okay, well, it worked the second time. I'm surprised it didn't give me an error message the first time. But again, we know that the slope was supposed to end up being 18, the slope was supposed to end up being 1877. Why is the slope second? What does my query say again? Go back to the design. Why can I not change? Oh, SQL view. I created M up here and I unioned it to the B value here. It feels to me like when I display it into a table, the B value is coming out first up top and then the M value. So that's a little bit weird. But also, does this B value make sense? This B value is saying that when that line, that perfect fitted line, crosses the y-axis, the median California salary was negative $3,692,256,256.50. How does that make any sense?
Is it because you started the X at like 1995, so then it goes down?
Oh my God, you're telling me to check my SQL code? What is year? What is year in California income? Oh my God, I was using the years. What would happen if I changed all of those years to 0 years there? Let me try. How fast can I be with this? Can I do Control Z? Nope, I cannot. So, 0. Control C. V, Control V, Control V. Let me know if I miss one, because otherwise it will return nonsense.
Is there a find and replace?
There probably is. It's faster for me to do this than find it in the menu system, if it exists. All right, I believe this works. Let me run it. Query design, run. This, again, we know as the, why is the slope ending up on top this time? This is just weird. But yeah, here, this tells me that in year 0, that is on the y-axis, the median California salary was $52,857. So this is why I like that using that 0-year column as the input, because, you know, M and B make sense to me. The M never really changes despite which column we use for X's, but the B actually makes more sense to me in this particular case, even though it kind of annoys me that I'm not using the real year values. I am using something derived from the year values, so in a way I am using them. And I do like that this gives me a more explainable y equals mx plus b equation. I mean, I think your roommates will be much more impressed with these two values than that -3 millionth value tonight when you're entertaining them with this problem at the dinner table. Yes? Yes, is that what you're doing, Devin? Perfect. That's all the time that I have for today. Thank you very much for your attention, for showing up. These next few class periods, you probably want to miss as few of them as possible. Most of them will be trained on these assignments that I'm going to start dropping on you in the coming weeks. Thank you for your attention. See you on Wednesday.